We are going to be reviewing from Unit 7 tests. We covered a lot of different topics, so we're going to go over the main points of all the different topics we talked about. First, we talked about the triangle inequality theorem. All that's stated is that any two sides added together on a triangle should be bigger than the third. So the sum of any two sides is bigger than the third side. So if I had 12, 6, and 10 as my sides, if we were going to prove if this was a triangle or not, we would add together two of the sides and see if they're bigger than the third. If I add together 12 and 6, I get 18. Yes, that's bigger than 10, so we're good. If I add together 6 and 10, yes, that's bigger than 12. We get 16, so that's bigger than 12. Yes, I'm good. And then left we have 12 and 10. It's 22. That's bigger than 6. So yes, this would make a triangle. I could make a triangle with those three sides. Also with that, we talked about the range of the sides. If I'm just given two numbers, say we have 8 and 15, we would find the top end of our range by adding these two numbers together. That's the biggest I could be without actually hitting 23. I could be 22.5 or 22.9. I can't actually be 23 itself. And I subtract to find the smallest value. So bigger than 23. Sorry, smaller than 23, because 23 is the biggest. Smaller than 23, bigger than 7. I could use any values in between that to make a triangle. If I wanted my third side to be 24, that wouldn't work. If I wanted my third side to be 23, that wouldn't work. But if I wanted my third side to be 22, that would work because it's smaller than 23 and bigger than 7. With this triangle inequality theorem, we also discussed the correlation between the angles and the sides of a triangle. When we look at the triangle, a side takes two letters, so side AB would correspond to the angle across from it. It would go with angle C. So if AB were the biggest side, C would be the biggest angle. Or if AB is the smallest side, C would be the smallest angle. And then also in that first section, we talked about the mid-segment theorem. So mid-segment theorem talked about the fact if we take a triangle and draw in its mid-segments. A mid-segment is made by connecting midpoints. If I put a midpoint, it's in the middle of the sides, and I connect those lines, then we know two things. If I used a mid-segment, then those two lines are parallel. Also, we know the inside is half as big as the outside. So if the outside is x, the inside would be, let's actually make the inside x. The outside would be 2x. It's twice as big. So if the inside is 5, the outside would be 10. If the outside is 12, the inside would be 6. So usually with our mid-segment theorem, we came up with the formula. We take the inside times it by 2 to equal the outside. And that's our main formula we're going to use for the mid-segment term. Inside times it by 2 equals the outside. So next we talked about circumcenter, centroid, orthocenter. You are going to need to have those memorized. Now those take a long time to talk about. So I'm just, for that section, going to have you refer to your 7.2 notes. You should study those because you need to have them memorized for the test. If you need to, go back and watch the 7.2 notes again. So then the last half was mostly focused on proportions, proving things similar. So when we proved triangles similar, I'm going to just use the triangle symbol to mean triangle. We had 3 options: side, angle, side, 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 or angle, angle. And this only worked for triangles. If we have similar shapes, we can always set up a proportion. But if we need to prove something similar, it has to follow one of those 3. So when we're proving triangles similar, if they give us the sides, we've got to set up a proportion. So usually we had something like this, where we might have to look at it and say, well, really, there is more than one triangle here, even though my picture looks like I only have one triangle. We have the inside triangle, which has a side of 5 and a side of 6. We have the outside triangle, which has a side of 10 and a side of 12. Now if we're going to prove these similar, we've got to set up a proportion to show that these are the same. And then we also have to identify if they share an angle. The blue triangle and the green triangle use that same angle on that left side of this picture. So that angle matches. The angles have to match, but the sides have to be proportional. So we had to set up a proportion to check and see if these were similar or not. If I picked 10 over 5, I'd pick corresponding parts. 10 was the top left side of the green triangle, so I have to pick the top left side of the blue triangle, 5. Well, now I go to the other one. 12 was the bottom of the big triangle, so I'm going to use 6, which was the bottom of the blue triangle. Then we can either cross multiply in order to see if the 2 sides are the same, or this one I could divide to see if the 2 sides are the same. Yes, the 2 sides are the same, so yes, this is similar. They gave us a side to an angle to a side, so by, side, angle, side. And if I gave them names, so M, S, N, P, Q, we could also set up our triangle similarity statement. Triangle MSN is similar, where they're proportional, it's similar, not congruent. Similar to M, we have to go in the same order, so we went from M to the bottom right, so M to Q to P. Now if I tell you the shape is already similar, we just set up a proportion and solve. So if I tell you the shapes are already similar, and then I can either say find x or find the missing length. They mean the same thing. If I say polygon, I can use any shape I want. We just have to look for the corresponding sides. Now maybe this shape was rotated. So let's say this side is x minus 2, this side is 10, this side is 5, this side is 4, this side is 3, this side is 5. Well, we have to pick our corresponding pieces when we set up a proportion, and we may have extra information. So I must always pick x first. It's a must. I must pick x minus 2. So x minus 2 is this side here. If I were to find the corresponding part, we have to look at the shape pretty closely. I kind of made this bottom piece here by the 5 pretty short. So that probably goes with that really short piece, which means we would go here to get the corresponding piece. Now, we have some extra information. This 5 at the bottom that I highlighted already, it didn't have any other information over there, so I can't use it. It's got to correspond to something. This 5 on this longer side here would probably go with this piece, but that didn't have any information. So we're left with using the 10 and the 3. So we started with x minus 2. We have to go from the same shape. So same shape, we would start with 10 over 3. Then we cross multiply and solve. When we cross multiply, we must multiply the 3 by everything over here. 3 times x is 3x. 3 times 2 is 6. 4 times 10 is 40. Add 6 to both sides now to solve this equation. And then divide by 3. So x is, let's see, 15.3. That one we did happen to get a decimal. Most of the ones on the test you're probably going to get whole numbers. But for the examples, I often just make them up quickly so they come out as decimals. So we had proportional shapes. We can also have proportional pieces. This one, I don't have to tell you the shape is similar. I just have to know that if I have an angle bisector, and actually I should draw the line first, because I'm going to mark these a little offset to show, hey, those are the same. I should know if I have an angle bisector, or if I have parallel lines, that they are automatically cut into proportional pieces. I don't need to tell you that these are similar. We should know by the way the shape is drawn. So let's say the entire thing is question mark. This is 7. This is 12. This is 10. So question mark, we can replace right away with x. But I need this piece here. It's the parts of this shape that are proportional. By the way it's drawn, then the parts are proportional. So I need this piece here. I have to take the entire length, x, and take away the piece I don't want, 7. So that piece there would be x minus 7. Once I have that, now I'm ready to set up my proportion. And start with x minus 7. And we could really start with any of the 4 pieces. Now x minus 7, I have to compare it to something nearby. I have to use either the 10 or the 7. I cannot use the 12. The 12 is too far away. So x minus 7 over 10, and then we would get 7 over 12. And then we would cross multiply and solve again. Now we've practiced a lot with our cross multiplication, so I'm not going to worry about that to try and keep these review notes a little bit shorter so they don't take forever. And then what we've talked about most recently is isosceles triangles. Now, isosceles triangles have a special property. If those two sides are the same, which they have to be in order to be an isosceles triangle, then the angles that correspond to those sides are also the same. If you think back to what we talked about at the beginning of these notes, we said this side here corresponds to the angle across. And this side here corresponds to the angle across. Those angles are the same. So if I were to tell you that this was 10, well, we know the sides are the same, so this would also be 10. Or if I were to tell you the angle is 23 degrees, so would this angle also be 23 degrees. What might happen on these ones is maybe we have to set up an entire equation saying it all equals 180. This is 2x, and this is 35 degrees. Well, the sides that correspond to the angles, so the sides that have the marks correspond to the angles across, means that because this angle was 35, so is this angle. This angle is also 35. Well, it wasn't super convenient for us. We couldn't just say x equals 35. But we could set up an equation with all those three things. We know the three things inside a triangle, the three angles inside, add to be 180. So if I add all those together, we combine my terms, 35 plus 35 is 70. I can now solve this equation. Do opposite operations, so I minus 70 from both sides. Get rid of the 2, we divide. We would get x is 55. So those are the main topics of our unit. We will be working on our review tomorrow, and then we will test on Monday.